All right, folks, it's back in action here. On this video, we're going to go through some just basic information that you're going to need to know for our rotated conics. So we're just going to go through some of the basic points, and then in the next video, we'll go through a complete process and how the whole thing all fits together. So what we're going to do in this section is we are going to take the conics that we've been studying and we're going to graph them on a different axes. So as you look over here to the top right, you can see I have the traditional XY axis, and then I have this other XY axis here. And what's happened is we took the original axis and we've rotated it by some amount. We're going to need that because sometimes we'll be given the equation for a conic that is more easily graphed on a rotated axis instead of the traditional axes. Now, when we get to, if you go to the other video on the playlist, the page 24 video, I'm going to walk through these little equations, these rotation equations that we're going to use. In order to get our equation in a form that we can actually graph it, we're going to need to use these two special equations that will allow us to rewrite our equation. And I go through a proof on the other page to help you understand where they come from, and sometimes seeing that background also helps you remember them a little bit better. So just know we're going to use these equations in the next video, and then I have another video that shows you where they come from. Now, what does it look like when an equation or a conic has been rotated? How would we even know that that happens? Well, a conic has been rotated if, when we look at the equation, we find an XY term. So as we scan along an equation, as we scan it from left to right, if we find an XY term, then we know that that conic is going to be more easily graphed on a rotated axis. So what we would do is we are going to identify this A, B, and C. So there'll be an A, a B, and a C. The A will always be in front of the x squared, the B will be in front of the xy, and C will be the coefficient on the y squared. We're going to find those values, and then we're going to calculate these discriminants, okay? And we'll be able to tell if it's a parabola, an ellipse, or a hyperbola based on that discriminant. So if we calculate the discriminant and we find that it equals 0 exactly, then it's a parabola. If we find that the discriminant is less than 0, then it's ellipse. It's an ellipse. Remember, it could also be a circle because our circle is just that very, very special case of an ellipse. And if the value is more than 0, it will be a hyperbola. So let's take a look at some examples here. We're going to find our A, B, and C for each of these. So we would identify the A, our B, and our C, and then we'll just quickly calculate that discriminant. So we'll have our B squared is our 9 minus our 4 times our 2 times our 2. Then we'll have a 9 minus a 16. I don't actually care what the actual value is. I just need to understand that it's less than 0. So this conic, when I go to graph it, will be an ellipse. That's going to help us know the form we need to write it in and what we can expect it should look like at the end. So on our next one, again, we'll find the A in front of the x squared, the B in front of the xy, the C in front of the y squared. We're going to calculate B squared, 144, minus 4 times 3 times 4. That's going to give us our 144 minus our 48. That's going to be more than 0, so this will graph a hyperbola when we're done. And again, on the next video, I'm going to go through how this all fits together. On our next one, we've got our A and our B and our C. So when we square that 2 radical 3, we're going to get a 12 minus our 4, 3, and our 1. That's going to give us a 12 minus a 12, which is going to be 0. So this one's going to be a parabola. Okay, so that's the first thing that you'll do on each of the problems is you'll just figure out what type of a conic you actually have. Then what you would do is you would figure out how much you should rotate the axes. So instead of them keeping their traditional vertical and horizontal, they're going to need to be rotated. So you need to know that angle of rotation. We're going to use this other new formula, okay? And again, you have to know it. So we're going to use this other new formula. And one of the little tricks that I like to do when I'm using this formula is I'll go through and I will identify my A, B, and C. I'm going to do that on all three of these here. my A, my B, and my C. And then I like to give myself this little link, this little A to the C, because that reminds me that the numerator is A minus C. So what I'm going to do is I'm going to say cotangent 2 theta is going to be 1 minus 1 over a negative 4. So when I clean that up, I have cotangent 2 theta equals 0. So I need to figure out my angle. So the first thing that I'm going to think about in an easier fashion will be to think, where is just cotangent equal to 0? I don't know why that highlighting turned out kind of weird on that one. Where does cotangent equal 0? Cotangent equals 0 at 90 degrees. So that means 2 theta equals 90 degrees, which means my actual theta value is 45 degrees. Okay, let's try another one. We're going to connect our A and our C. So we're going to say cotangent 2 theta. We're going to do 11 minus 1 this time over 10 radical 3. Now we can clean that up, and that's going to give us a cotangent 2 theta equals 1 over radical 3. So then we're going to think, where does cotangent equal 1 over radical 3? That means that my 2 theta is going to equal 60 degrees because cotangent is 1 over radical 3 at 60. So my actual angle of rotation is 30 degrees. Now this last one that we're going to do, you're going to need your calculator for this one because this one's not going to come from our unit circle. So on this one, we're going to say cotangent of our 2 theta. Remember, link the A and the C. That helps a lot of people. So we're going to say 1 minus 4 over 4. So we have this cotangent 2 theta equals a negative 3 over 4. Now, this doesn't come from our unit circle, which means we're going to have to type this into our calculator. So when we type this into our calculator, what we're actually going to type in is we're going to type in an inverse tangent. And then since we're using tangent instead of cotangent, we're going to flip the ratio. So we'll have a negative 4/3, okay? When we type that in, that'll tell us what 2 theta is. So now it's going to tell us that 2 theta is a negative 53. I'm just approximating this right now. Now that's the 2 theta and it's in the wrong quadrant. So remember, the calculator is going to give it here, but cotangent is actually negative in this quadrant. So what we're going to do is we're going to take that negative 3 and we're going to add our 180 to it so that we can actually say that 2 theta is our 126. So our actual theta is 63.4. Now I kept that decimal running even though I didn't write them here on the video. So remember that when you flip that, we're going to move it to the proper quadrant before we divide by 2. Okay, on the next video, we're going to put everything all together.